Hi, Algebra 2. Here is the beginning of a new chapter, chapter 4. We're going to cover quadratic functions and factoring in this chapter, okay? This should also be a little bit of review from Algebra 1, but like I said, Algebra 1 was 2 years ago for all of us, and quadratics were a little bit more difficult. So um, if you're at all at this point in this chapter getting stuck, don't worry. Quadratics are usually a little bit of a hairier subject, but we're going to get through it, okay? We're going to start with section 4.1, graphing quadratic functions in standard form. Okay, so let's start with a few definitions. Our first one is a quadratic function is a function that has the standard form. So remember, we had a standard form for a linear equation. Now we have one for our quadratic functions. It's going to be y is equal to ax squared plus bx plus c. Okay, and actually I'm going to go ahead and rewrite it a little bit just so you can see that better, the first term. It's a is the coefficient, x to the power of 2. That's a little better. And then we have one little condition is that we'd want a to not be 0. Okay. Why do you think we don't want a to be 0? Well, if a was 0, then we don't have a quadratic. We actually have a linear function, right? Bx plus c. That looks kind of like mx plus b, right? So that's kind of why we don't want a to be 0. And then we call the graph of a quadratic function a parabola. The graph of a quadratic function is called a parabola. And let's go ahead and take a look at that really quick. Let's go ahead and graph a parabola. If you remember what that looks like, it's kind of that U-shaped looking dude. But let's go ahead and just, let's create a table of values and just see where we get that parabola shape from, okay? So our function is y is equal to x squared. Here are some x values we're going to use. So then, for the first one, we're going to do -2 squared. And then, be careful here because this always kind of catches us a little off guard. Sorry, a tongue twister. -2 squared, I'm doing -2 times itself. So -2 times -2. That's positive. 2 times 2 is 4. Okay, so at -2, my y value is 4 right here. Okay, if these are, this is -1, -2, -3, 1, 2, 3, etc. Okay, next one, we got -1 squared, -1 times 1, sorry, -1 times -1, positive 1. So at -1, we're at 1. 0 squared, you should be good with that one, right? 0 times itself is 0. So we have a point at the origin. And then 1 squared. 1 times 1 is 1. And we'll just do the last one. 2 squared. 2 times 2 is 4. Okay, so we get this symmetry. 1, 1, and 2, 4. Hopefully this picture is starting to look a little familiar. Now we just connect the dots. Let's see if I can do this pretty decently on here. Mine's going to look a little ugly, but yours should hopefully look pretty decent. Okay, and it continues onward. Maybe make it look a little nicer. As nice as it can, right? Okay, so here is our quadratic function. This is actually, I'm gonna scroll down a little bit. This is actually the parent function, right? We graphed y equals x squared. This is our parent function for the family of quadratics. So all quadratic functions, all parabolas look like this, just, either stretched, shrunk, translated, reflected, etc. You should maybe hopefully remember that a little bit from Algebra 1, those transformations, right? Reflections, shrinks, compressions, etc. If you don't, again, that's totally fine. We're going to talk about that a lot in this chapter and then in future chapters as well. Okay, so then Two more definitions before we continue. And we're going to scroll back up in a little bit. Oh, I did not mean to bring that up. Okay. So parent function, now we have the axis of symmetry is a vertical line that divides the parabola into mirror images. It passes through the vertex, that's another term, which is the lowest or highest point on the parabola. Okay, so let's identify those things on the one we drew above. Now, one thing to understand is that the axis of symmetry, it's not part of the parabola, it's just something that we can add on to kind of give us an idea of how to graph the parabola. In this case, we don't really need it because the parabola was easy to graph. We could just plug stuff in. In other cases, we might want to, because we're lazy, we don't want to plug in a bunch of we don't want to plug a bunch of x values into a table. We might use the axis of symmetry to our advantage, and we'll see how that works in a little bit. But the axis of symmetry, it divides the parabola into mirror images, and it's a vertical line. So it's going to cut through the vertex, which is the lowest, highest point. In this case, it's the lowest. Here is our vertex. This is our vertex. And the coordinates are 0, 0. Okay, let's change colors here really quick. And then we have our axis of symmetry, which cuts through the vertex and it cuts the parabola in half. So if I were to show the axis of symmetry, this is what it would look like. And it just so happens to be the y-axis. So this is our axis of symmetry. Okay. So we identified lots of different things. We identified a vertex, we identified axis of symmetry. We talked about it being our parent function, being y equals x squared. Go ahead and, rewatch this video if you need to, because we did cover quite a few terms just now, that are all part of the quadratic function. Okay, so let's do some examples and then we'll end this video. Okay, so we're gonna go ahead and graph the following quadratic functions and identify the axis of symmetry. Okay, so for now, we still only know how to graph these using our table of values. Let's just do that, okay? So x, sorry for my not really straight lines, and then y is equal to 2x squared. And then actually, I'm gonna go ahead and use a different color to show our y values. Y is equal to 2x squared. Okay, so we have negative, we're gonna use the usual ones that we have been, -2, -1, 0, 1, 2. So then -2, we're gonna plug that in. Notice that it's 2 times -2 squared, okay? That's a lot of 2's right there. Be careful here because there's a certain order we gotta do this, right? Let's do our exponent first. -2 times -2, that's 4. 2 times 4 is 8. Okay, so at -2, my y value is +8. So all the way up here. Next one, 2 times -1 squared. -1 times -1, that's +1, is equal to 2. 2 times 1 is 2. So then at -1, my y value is 2. And then here with 0, 2 times 0 squared is 2 times 0, 2. Let's just go ahead and finish this out. 2 times 1 squared is 2 times 1, which is 2. And then 2 times 2 squared is 2 times 4, which is 8. Ooh, I'm sorry. You're probably looking at me like, what is this guy doing? This should be 0. Okay, it's a good thing I caught it before I kept going. Okay, so let's plot some of these zeros, 0, 0, 1, 2, 2, 8. And then we make our pretty parabola. Well, yours will be pretty, mine's kind of chopped. Mine's a little clapped looking. Okay. Like I said, hopefully yours looks nicer. All right, now let's go ahead and find the vertex and axis of symmetry. Now, in this case, if you notice, it's not going to be really different. It's not going to be that much different from our parent function, our x squared, right? If you notice, the only difference between our current parabola and x squared is that it's just a lot skinnier, right? Remember that when we have a number multiplying outside of our function, that's going to stretch it vertically. That's going to make it skinnier. Okay, so our axis of symmetry, let's just do it because it's kind of what it's in the problem. So here's our vertex. 0, 0. And then our axis of symmetry cutting through the vertex. I'm gonna be lazy and abbreviate it AOS. Okay. Let's go ahead and do 2 more examples, and then I'll go ahead. There should be one for you to try, or a few for you to try. All right, next example, we have 1/2 x squared, same thing. We're gonna make a table of values. X, and what color do we want to do this one? Let's do it in orange. Hopefully it's not too bright. Y equals 1/2 x squared. That looks decent. -2, -1, 0, 1, 2. So here for this one, 1/2 of -2 squared. That's going to be 1/2 of 4, which is 2. Same idea here, 1/2 of -1 squared. That's going to be 1/2 of 1. Oh, I don't know what it did. Sorry guys, give me a second. There we go. Sorry about that. Oh, no, I need to click on my pen. Here is 1. There we go. And that's 1/2, right? 1/2 times 1 is 1/2. It's itself. 1/2 times 0 squared. We know 0 squared is 0, so this guy is just 0. 1/2 of 1 squared. We know 1 squared is 1, so this is just 1/2. And then you can probably guess what this one is going to be, right? It's going to be 2. Okay. Now, hopefully you're noticing a little bit of a pattern. When we do, let me use a different color. When we do the inside of the parentheses, so this stuff right here, when we square it, we're getting the same y values as our parent function, right? 4, 1, 0. And if I showed the work here, it would have been 1, 4. And then hopefully you notice that in A as well, we got 4, 1, 0, 1, 4 before we had to multiply each of them by 2. Okay, so kind of keep that in mind as we start talking about transformations pretty soon here, okay? In the meantime, let's just go ahead and graph this thing. So at -2, we're at 2. At 1, sorry, at -1, we're at 1/2, so somewhere there. 0, 1/2, 2. And then maybe we can kind of guesstimate one more point. At 4, 4 squared is 16. Half of 16 is 8. So we know that at 4, we have a point here. Same idea at -4, a point there. Just to make a prettier parabola. Ooh, this one might look nice. Nope, I jinxed myself. It looks pretty crappy on that side. Yeah, you get the idea, right? Same thing, our vertex is still at 0, 0. And if we went ahead and added an axis of symmetry, it's still cutting down there. So you're probably just like, well, that's really boring. I want the axis of symmetry and the vertex to be different, at least once, right? So maybe ask yourself, maybe like, pause the video as soon as I ask you this question. What do you think, like, what do I have to do to y equals x squared? Like, what kind of transformations? Either multiplying like I did here, or adding or subtracting, whatever. What do I need to do in order to maybe get a different vertex or a different axis of symmetry? Okay.